Hi guys, and welcome back to the ACE Academy. In this video, we'll be looking at the horizontally shifted hyperbola. On your screen right now, you guys can see that I have sketched a hyperbola on a Cartesian plane. This hyperbola, I'm going to give the equation y is equal to a over x. Now, the first thing I want to highlight to you guys is the important points of the hyperbola and how we are going to quantify or define this hyperbola, or any hyperbola for that matter, so that we can understand it a bit better. The natural hyperbola, or a hyperbola that hasn't been shifted vertically or horizontally, will always have an asymptote at the values of x is equal to 0, and that will be a vertical asymptote, right? That is your y-axis. So I can say this is my vertical asymptote, and at a y value of y is equal to 0, and that would be our horizontal asymptote, which is in fact our x-axis. So in order to define this hyperbola, we would need to know the value of its vertical asymptote, the value of its horizontal asymptote, and any point on the hyperbola. And the significance behind knowing any point on the hyperbola is it would allow us to determine which quadrants the hyperbola lies in. Now I want to highlight the nature of the hyperbola for you guys, because I want you guys to notice that the hyperbola only exists in two quadrants at a time. And when I speak about the two quadrants in which the hyperbola exists, I'm speaking about the quadrants that are created by the vertical and horizontal asymptotes of the hyperbola. And the reason behind that is, if I were to shift this hyperbola maybe to the right, maybe upwards, the hyperbola might lie in more than two quadrants. But if I'm looking at it with respect to its asymptotes as its axes, I would be able to correctly quantify it into its correct quadrants. Okay, in this case, the hyperbola lies in the first and the third quadrants, which tells us that the hyperbola is positive. So if I know any point on this hyperbola, I would be able to determine what shape the hyperbola would have. Okay, in this video, we are going to be focusing on the horizontal shift when induced into this hyperbola. And this is done by manipulating the value of its vertical asymptote. Okay, and the reason behind that is, if I were to shift this vertical asymptote, let's say 3 units to the right, my hyperbola, the entire hyperbola, would shift 3 units to the right. So simply by manipulating the values of its asymptote, I can manipulate the position of the hyperbola on the Cartesian plane. This is very similar to the manner in which we manipulated the y value, or the horizontal asymptote, because when we induced a vertical shift either up or down, we just simply moved the position of its horizontal asymptote, right? So in this case, we are focusing purely on the vertical asymptote. If I were to induce a horizontal shift in this hyperbola, my equation would look like this. Y is equal to a over x minus p. Okay, and this minus sign is very, very, very important. We must never forget about the minus sign, because it would affect the shape of the hyperbola. And I'm going to expand on that a bit further as we progress in this video. But what I'm interested in now is this p-value that I've introduced into the equation. What is the p-value and where does it come from? Very simply, the p-value is the x value of the vertical asymptote. Right, guys? It is the x value of the vertical asymptote. So in this case, the reason why the equation of the standard or the natural hyperbola that has been unshifted is a over x, is because we are essentially saying a over x minus 0. P is our vertical asymptote, right, guys? So if I wanted to shift this hyperbola to the right, right? If I wanted to shift this hyperbola to the right, I would have to give this hyperbola, I would have to give the vertical asymptote of this hyperbola a positive x value. Is that correct? Because if I'm moving to the right, all of these regions are positive x values. Understand, guys? So if I were to say I'm shifting this hyperbola 2 units to the right, I would have to move my vertical asymptote from an x value of 0 to an x value of positive 2. So let me go ahead and sketch in the new vertical asymptote, and I'm going to sketch it in blue so that you guys can see the difference, right? So this new vertical asymptote that I've created has the equation of x is equal to 2. In order for me to find the correct equation for this hyperbola, I would simply have to substitute in the 2 value for p. So that would give me y is equal to a over x minus and a positive 2 on the inside of this bracket. If I expanded this denominator for this fraction, I would get y is equal to a over x minus 2. Now, if you guys look at this equation right here, you can see that I simply cannot take minus 2 as the value of my vertical asymptote because, hey, my vertical asymptote in this case is positive 2. So in order for me to get the x value of the vertical asymptote, all I would have to do is multiply this value in the denominator, the value associated with a number without a variable of x, by minus 1. So the x value of this hyperbola's vertical asymptote is minus 2 times negative 1, which is positive 2. And that's all because of the minus sign in the equation. Can you guys see that when I subtracted something from the x value in this function, I moved it to the right? What would happen if I added something to the x value of this function? I'm just going to pause right there, and I'm going to complete sketching in this hyperbola so that you guys can see what my intention was for showing you this equation. And then we're going to go ahead and investigate what would happen if I added something to x, right? So if I were to sketch this in this hyperbola, it would look like this. Notice how it is the exact same hyperbola. It has just been shifted to the right. Now let's go ahead and look at what would happen if I added something to the x value in my denominator. So I'm going to go ahead and give this new function the equation of y is equal to a over x plus 1. Now in this case, in order for me to obtain the x value of the vertical asymptote for this new function, I would have to look at the type of manipulation that's being applied to this function. When I add something to x, I am moving to the left, correct? So if I add, I move to the left. If I subtract, I move to the right. Now, if I'm moving this function to the left because I'm adding a value to the x, what would happen to the value of the asymptote? It would shift 1 unit to the left, correct? So let's go ahead and just make a mark over there so that you guys know what I'm talking about. In order for me to find the x value of the vertical asymptote for this function, I'm going to multiply the positive 1 over here by negative 1. And positive 1 times negative 1 will give me a value of negative 1. And hey, look at that. That is the correct value for the vertical asymptote of this function. I'm going to sketch that in quickly for you guys. And if I were to sketch in this function, it would have a shape that looks like this. Okay guys, so in order to see the shape of this function, I want you to look at the green graph that I've plotted, the green hyperbola, so that you can differentiate between the types of shifts. Okay, you guys don't have to worry too much about the shape itself, but understanding the way the shape works in a hyperbola would allow you to understand how the x value of the vertical asymptote is found. That's very important. So simply put, if you want to find the x value of the vertical asymptote, you would have to look at the p-value and multiply it by -1. Or rather, you would have to look at the value that's being added or subtracted to x and multiply it by -1 in order to obtain p. I think that's better worded, right? So that is just the x value of the vertical asymptote. In order to understand the type of shift that is happening to the hyperbola, if something is being added, it is moving to the left. If something is being subtracted from x, it is moving to the right. Understand? It's quite simple. Maybe it's a bit intricate to grasp at first, but once you understand it, it makes your understanding of the hyperbola much better. It makes it much easier to work with. That's it from me, guys. All the best, and I will see you in the next one.